All right, geometry gurus, let's talk about dilations in the coordinate plane. We did dilations using a compass and straight edge and construction techniques, so now we're going to do dilations on a graph. So we're going to start off with segment AB, segment on the coordinate plane with endpoints at -2, 1, so that'll be coordinates for point A, and 1, -2, that'll be the coordinates for point B. And we're going to dilate the segment from the origin by a scale factor of r equals 4. Then we're going to get another segment that is produced. I'm going to show you how to do a dilation on the coordinate plane. As long as the dilation is centered at the origin, we're just going to use multiplication. In general, the rule for doing a dilation centered at the origin on a graph is to take the scale factor and multiply it times each coordinate. So I take the scale factor of r times the x coordinate and the scale factor of r times the y coordinate. It's pretty much that simple, and then you just plot the new points. So if I take the point -2, 1, which is point A, and then 1, -2, point B, in order to do a dilation of a scale factor of 4, basically what that means is count the distance using the squares on the grid, kind of like you would count slope. So with the compass and straight edge, we would go from the center of dilation, draw a line from that center of dilation through the image point, so that would be up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. So connecting those yellow dots would basically be like our straight edge connecting the center of dilation through point A. Then what we would do is measure the distance from the center of dilation to A and mark that off 4 times. So it would be 1, 2, 3, 4. That's the new location for A prime. But the rule for that would come from looking at the coordinates of A prime, which is now -1, 2, 3, 4, 5, 6, 7, 8, -8, 1, 2, 3, 4, 4. So the coordinates of A prime would be -8, 4. And comparing that to the original point of coordinates for A, -2, 1, the scale factor of 4 took the original coordinates of -2, multiplied it by the scale factor of 4 to get the new coordinate of -8. And then the y coordinate of 1 times the scale factor of 4 gives you the new y coordinate of 4. So that makes it much easier than having to do the counting on the graph, because what we can do is just look at the coordinates for point B, multiply each number times 4, so the x value of 1 times 4 is 4, and the y value of -2 times 4 is -8, and then just plot that point. 1, 2, 3, 4. And there's B prime. So that is a lot easier and a lot less work than having to count. And of course, the image is parallel to the pre-image, and we should know what's going to happen if we try to find the lengths. So if I did the Pythagorean theorem with AB by making a right triangle here, and then use the Pythagorean theorem to find the length of AB, a squared plus b squared equals c squared, and I ended up with 3 radical 2 as my distance, then what would I get for A prime, B prime? Well, the long way around it would be to drop an altitude and the base and do Pythagorean theorem again. But if we know the scale factor is 4, then what we have to do is take the original length, the pre-image length of 3 radical 2, multiply it times 4, so we end up with a new length of 12 radical 2. And conversely, working backwards, going the other way, if I know OA prime, that would be from the center of dilation to the image point. If I know that length is 4 radical 5, what is the distance in the pre-image? So we would take our 4 radical 5, and this time, since we're working backwards, finding the pre-image length, we would divide out the 4 and get just radical 5. The slope of AB is down 3 over 3. So the slope being down 3 over 3 is negative 1. And the slope of A prime B prime, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, down 12, 11, 12, over 12, is exactly what we would expect based on things that we've talked about before, because the image is parallel to the pre-image. So they have equal slopes, and the image length is 4 times greater. So a line segment of length m is mapped to a line segment of length r times m. So the scale factor used can get multiplied by the original length to get the length of the image. And that'll work for all segments that undergo the dilation. A line segment after dilation is going to be parallel to the original. So it produces an image that is parallel to the pre-image. A line mapped to another line would also be parallel. So segments are parallel. A segment is parallel to another segment after the dilation, and a line is parallel to a line after the dilation, which kind of makes sense. And then if we have a circle, circle's still going to follow the same rules. If we have a circle that undergoes a dilation, then the new radius is the scale factor times longer than the original radius. So we multiply the original radius times the scale factor to get the new radius. All right, so we're going to do a scale factor of 3 on triangle ABC, where A is the 0.31, B is the 0.61, and C is the 0.35. So what we would do is multiply each one of those coordinate values times our scale factor of 3. So 3 times 3 is 9. 1 times 3 is 3. 6 times 3 is 18. 1 times 3 is 3. 3 times 3 is 9. And then 5 times 3 is 15. So pause the video, graph the original triangle ABC, and graph the image after the dilation, A prime, B prime, C prime. Graph those, and then come back. And bada big, we got our triangles graphed. So now let's compare the slopes of AB and A prime, B prime. Well, AB and A prime, B prime are both just horizontal lines, so they're both going to have a slope of 0. So the slope of AB is going to equal 0. And the slope of A prime, B prime, as expected, and as we should be understanding consistently now, that the dilation is going to produce images that are parallel to the original. So all 3 sides of the image are parallel to their corresponding sides of the pre-image. So A prime, C prime is parallel to AC, C prime, B prime is parallel to CB, and then A prime, B prime, as we see in our slopes, is parallel to AB. So what's going to happen when we look at the lengths? Well, if we find the length of AB, which is just simply 3, and we find the length of A prime, B prime, we can just count that because it is a horizontal line on a graph, so we can count the number of spaces. That's going to be 9, which is exactly what we should expect because we underwent a scale factor of 3. So if we were to try to find the scale factor using the ratio of image length divided by pre-image length, it divides out numerically to be the scale factor that we used in the beginning. So all that makes sense. Now if we were to use Pythagorean theorem to find OC and OC prime, then we could get the comparison of those lengths as well. So why don't you pause and either use Pythagorean theorem or use the distance formula to find the length of OC and OC prime. Now these are not calculations you can count or lengths you can count because O being our origin, 0, 0, and then point C, and then 0, 0 to point C prime. So pause, do those 2 calculations, and let's see if you come up with the same results that I do. So if you're using the right points and using the right formulas, then we should get that OC is equal to radical 34, and then OC prime end up equaling radical 306. Simplifying the radical 306, we end up with 3 radical 34. So it does show that OC prime is 3 times longer than the pre-image OC. When we write the ratio of OC prime, which is 3 radical 34, over the pre-image OC, which is radical 34, the radical 34s cancel out, and we do get our scale factor of 3, just like we think we should have. So everything's falling into place, and now we're seeing mathematical examples of the lengths being multiplied times 3, which matches the scale factor. So for one of these sets of calculations, we use the actual lengths of the triangle, and then for the one we just finished, we calculated the distance from the center of dilation to the pre-image, and then compared that from the center of dilation to the image. And each one of those represents the same scale factor, comparing the actual side lengths or comparing the center of dilation to the image and pre-image points. We can use either one of those to find the scale factor. All right, number 3. Dilate triangle ABC from the origin with a scale factor of r equals -2, then describe the image after the dilation. So why don't you go ahead, find the coordinate points for point B, C, and D, because when you have those coordinate points, you can carry out the multiplication, and then once you carry out the correct multiplication, you can get the coordinates for B prime, C prime, and D prime. Then you can plot that triangle on your graph, and then you'll be all set. So do that, come back, and we'll compare. And bam, there we go. So now it says describe the image after the dilation. So if you look at the original image and our dilation, our scale factor of -2 pushed it in the opposite direction of the center of dilation. So if our center of dilation was 0, 0, the origin, instead of going from the origin towards that point and further beyond, we went from the origin in the opposite direction and double the distance. So what happened was our image is twice as big as the original triangle BCD, and it looks like it was rotated because we went in the opposite direction. It looks like it was rotated 180 degrees about the origin. So those two things happened because of the negative scale factor. It doubled the size like we're used to seeing, but also rotated and changed where it was located. All right, so now let's start building and remembering in some of these other transformations that we've done in the past. And we're going to start doing compositions of transformations and review and do some of the new stuff all together. So what I want you to do is write in and fill in as many of the rules as you can remember. If you have to look them up, that's fine. And then I'm going to have them all filled in for you. And then you can pause, fill in whatever you needed to fill in. Then we're going to use these to do some of the questions below. All right, so pause it, fill in the ones that you can, and then come back. So there's all the rules for you. The new one that we actually did write down on our lists when we filled this chart out, the dilations is when we multiply the scale factor times each coordinate. So it'll be k times x and k times y. All right, so now we're going to put some of these into play and do a composition on a specific set of points without using a graph. All right, so we need to remember the correct order of how to do these compositions. So when you're told to take triangle TRK with T is -3,6, R is -12,15, and K is 3, -9, find T prime, R prime, K prime after the translation of 7, -5, a dilation of -1/3, and reflection over the line y equals x. Remember that we start right to left. So the first thing we're going to do is the reflection over the line y equals x. And when you do the reflection over y equals x, you take the original points and you swap the x and the y. So then my new t value, when I switch, becomes 6, -3. my new r value becomes 15, negative 12, and my new k value becomes negative 9, 3. So now that first transformation is complete. The next transformation that we are supposed to do is the dilation of negative 1/3. So that means we are going to multiply each coordinate number times negative 1/3. So 6 times negative 1/3 would be the same thing as doing 6 divided by negative 3. So that's negative 2. Negative 3 divided by negative 3 is positive 1. 15 divided by negative 3 is negative 5. Negative 12 divided by negative 3 is positive 4. Negative 9 divided by negative 3 is positive 3. And then 3 divided by negative 3 is negative 1. So that's the second round of our composition taken care of. Now, the third piece to this would be the translation of 7, negative 5. So that means you're going to take each x value and add 7, and each y coordinate and subtract 5, and that'll give us our final values for our points. So for t, we'll end up with 5, negative 4. Adding 7 to the x, subtracting 5 from the y. For r prime, we add 7 to the x to get 2. Subtract 5 from the y to get negative 1. And then for k prime, add 7 to the x, making it 10. Subtract 5 from the y, making it negative 6. And there are the coordinates for our final image. So why don't you pause the video and try example 2 here. You're going to graph and state the coordinates. All right, so pause, give it a shot, and then we'll see what you end up with. So if you're doing this on the graph and you reflect over the y-axis, remember what we're going to do is just count sideways. So 1, 2, 3, 4, 1, 2, 3, 4. That's the new location of point S. And then 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That would be the new location of I. And then C, similarly, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that produces your reflected triangle over the y-axis. Make sure you're doing the y-axis, not the x-axis. If you're doing it with the coordinate rules, you would negate the x and keep the y value the same. When you reflect over the y-axis, the y stays the same. So you negate the x but keep the y value the same. You negate the x but keep the y value the same. So that would give you the same result as what we did on the graph. Now with the rotation, if you're doing the rotation on the graph, then that's when we turned the page, looked at the coordinates, and then plotted it, or read the points, and then turned it back. If you have the rule memorized, we're going negative 90. So make sure you're looking for the correct rule. The rule for negative 90 would be the same as positive 270. So that's the y negative x rule. So we are taking the coordinates that we just wrote down and applying the y negative x rule. So then the first point, it turns into negative 3, 4. Then it turns into negative 3, positive 7. And then the y goes to the front, negate the x and move it to the back. There's your 3 points, and then we can plot those to get our next triangle. So negative 3, 4. Negative 3, 7. And negative 6, 6. So there's our rotated triangle after the rotation of 90 degrees. Now taking those points and then doing a translation of 4, negative 5, that means add 4 to the x value, subtract 5 from the y value. Or on the graph, that means add 4 to the x, move it 4 sideways to the right, 1, 2, 3, 4. And then down 5, 1, 2, 3, 4, 5. We do that for each point. 1, 2, 3, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. And there's our translated triangle. If we did it using the rules and writing out the points, add 4 to the x value, subtract 5 from the y value, and we're going to do that to each pair of points. Add 4, subtract 5, add 4, subtract 5. And then our final image comes from taking these purple points and do a dilation of 4. So we're just going to multiply each coordinate times 4. And then once we have those, we have our final image coordinates that we can plot and graph. So 4, negative 4 would be s prime. 4, negative 8. I'm sorry, 4, positive 8. And then, oops, I prime. My last point was negative 8, 4. So after all that different changing in translations and rotations, reflections, we ended up with one triangle and all the right coordinates. All right. So now let's take triangle love with the given coordinate points, and I want you to do the composition and restate the coordinates, and then we're going to take a look at what happens when we do consecutive dilations, or 2 dilations in the same composition. So pause the video, complete the dilations, write the coordinates, and then we're going to quickly go through what the results show. So after the dilation of negative 6, we're going to multiply each of the given coordinates by the number negative 6 and plot a triangle. So our triangle looks like it's been rotated, and then now it's 6 times larger than the original. Now we're going to take those coordinates and perform the dilation of 1/3, and then we'll see what happens with that. So performing the dilation of 1/3 means I'm going to multiply each of my coordinates times 1/3, which technically means we are dividing it by 3. And then that's going to give us the coordinates of our final image, because then we'll be done with the composition. So that's going to end up with 2, negative 4. It's going to end up with 2, 0, and 0, 0. So that means we're going to have our final image right here. L prime, B prime, and V prime. So the 2 different scale factors that were used throughout this calculation were negative 6 and 1/3. If I use the graph to find the length of UV, the original length was just 1. If I compare that with U double prime, V double prime, my final image, it is 2. So how do we get a scale factor that takes our length from 1 to our length of 2 after doing a scale factor of negative 6 and 1/3? Well, if we look at the ratio that we've been using, image length over pre-image length, our scale factor from the original to the final image was just 2. So where does that come from, looking at the 2 different scale factors that we actually used in our calculation? Well, the 2 different scale factors we used in our calculation were negative 6 and positive 1/3. So how does our single scale factor relate to the 2 individual scale factors that were used? Well, if you take the scale factor of 6 the scale factor of 1/3, and multiply them together, you get the overall change for your final image. So your transformation and composition, if there is more than one dilation, and you multiply the different scale factors together to figure out the overall final change from original pre-image to the final image. If there's only one dilation, you use that one scale factor. But if there is more than one dilation, you multiply the scale factors together to determine the overall ratio from pre-image to final image. So you use the product of the different scale factors in the composition to determine the overall change in size. So, the line that contains the centers of dilation is parallel to the lines that contain the corresponding points of the images, and in a series of dilations, the scale factor that maps the original figure onto the final image is the product of all the different scale factors in those series of dilations. All right, so we did this in 26 minutes, kept it under a half hour, which is less than a full period of class. Hope you're all doing well. Good luck with doing the practice. It is important that you go through the problem set and look at those questions and try some of those questions and practice some of those things. It's not super long. And you can use the answer key that's in Teams to make sure you're doing things correctly. All right, so we have a quiz coming up. Make sure you're on top of things, and I will see you, talk to you soon. Stay safe.